It's the Azure Sydney User Group, featuring the new Azure Virtual WAN. Recorded live August 22, 2018. Here's Simon Waight.
That's a nice old picture of me. I actually look young in that picture. So I should probably have put the CBD meetup in this one as well. So the CBD meetup is actually next Wednesday at Tankstream Labs down in the city. That's on Bridge Street. And this month we're actually doing something that's probably applicable to some of the people in the room, which is talking about doing a voice activation sitting over the top of Microsoft Identity Manager. So if you've done any form of identity management work and you want to learn a little bit about using Azure Cognitive Services to build natural interface experiences over the top of something like MIM, would definitely recommend you come along to meet up next Wednesday. Former colleague of mine and Azure MVP, Identity Management MVP, Darren Robinson, is going to be demonstrating a system that he's built using Azure Cognitive Services and some voice activation. He's actually entered that into a hackathon to go ahead and build out kind of the full circle of the features so that actually you can allow admins to manage identities using their voices as well, and doing identified speaker in cognitive services as a way to control who can actually make those changes in MIM. So if that's a space that's interesting to you, still spaces available for that meetup next Wednesday down in the CBD. If you're here tonight, you will have seen the meetup invite anyway. Other events that are coming up, I'll come and stand over on this side so I can get my best side on the camera. Azure runs frequent, what they call discovery days, Microsoft runs frequent events called discovery days. There's one coming up in September here in Sydney that will allow you to get hands-on and to learn about the basics of Azure. So if you or people that you know want to learn more about Azure, these are good days to go along to. They're level 100, which means they're introductory, they're free, and they're well organised and run. When I get up here and I talk about these events, and we'll share these slides afterwards, if it's a bit hard for you to see, you'll be able to get them off of the meetup site. When I share these events, they come off of a learning pathways site that Microsoft runs, which lists all of the events that they run. So there are upcoming events for these types of specialisations in Perth, Canberra, Melbourne and Sydney over the next quarter, and then there'll be a repeat of those as well. I'm hoping we'll eventually see developer versions of those, because that's kind of my focus at Microsoft these days. But if you are wanting to learn more about Azure, that's a good place to start. What's next? These are just some ways that you can get more hands-on with Azure, learn a bit more about how to work with the platform. Microsoft's doing a really good job of building out content for you to just start to learn about more things inside of Azure. Maybe you're already quite familiar with certain things. Maybe you want to go deeper in an area that you don't know much about. These are good ways to do that. There's pre-built labs that you can get in and get hands-on with. The Virtual Academy is always good value. And Microsoft's teamed up with Pluralsight to build free training, or make free training available to you to get in and learn more about the Azure platform as well. And a local plug, an MVP out of Brisbane called Daniel Toomey set up a Slack channel called the Australian Azure Community Slack. You can go ahead and subscribe to that if you're on Slack. Really worthwhile. It's a bit quiet at the moment, but we're hoping to drive a bit more engagement. If you've got questions, you want to get support from peers in Australia, that's a good place to go ahead and get access to it. As I said, we'll put these slides up on the meetup site afterwards if you want to get access to that channel. All right, so just to show of hands, who's been to one of these before? Okay, a few. All right, so the way Microsoft does releases of features in the Azure platform, they'll start typically with a private preview of some variety. These are either publicised, so you can go and find about them in some form of announcement, or your organisation might be a member of an NDA program with Microsoft where you might be invited to participate in them. But private previews are closed, small groups of people that are helping Microsoft test early concepts of a particular solution, where you can go in and you can actually use the service in a non-production capacity and give the product group teams that are working on these services feedback to help them shape the final offering. So when we talk about private preview, these are things you generally need to be invited to. So if I talk about them here, it means that they're public private previews, if that makes sense. So it's something you can go and discover and sign up for rather than being invited. Unfortunately, both of the ones that are up here at the moment are US and EU only. But if that's not an issue for you in terms of testing out the service, you can still request to be a part of that if you want to. So the two that we have up here, and you may have seen some of these previously, the Azure Data Disk or Data Box Disk. So Microsoft already announced the Data Box, which is the equivalent of the AWS Snowball device, where you can actually bring a device in, attach it to your network, transfer large volumes of data onto that device, and then ship it to Microsoft, and they will load it into a storage account in your Azure subscription, so you can more easily transfer large volumes of data across into the Azure cloud. This is a smaller scale revision of that. As the name suggests, it's literally down to kind of a disk type of form factor. So rather than being a kind of a sizable device, you're now talking at a much smaller scale. So the SME market may be better suited to using this. Again, only available in EU and US at the moment, but worth having a look at if you don't maybe need, terabytes and petabytes of data to be transferred into Azure. And then the other one is Service Bus Premium being available in a redundancy model called availability zones. This is quite useful because it will allow you to have that availability zone redundancy for your service bus queues or topics, which you can't get unless you're on a premium tier. If you do a lot of sort of enterprise level messaging, something that it's worth having a look at for you. Any questions? No? Good. Oh, yes? No? No? When's the food coming? I think it's already here, I think. I'll be quick so we can get some food before we do the cut over to Marc and Nathan. Public previews. So these are services that generally don't need to be a part of any program to access. You just need to have an Azure subscription. You can log into the portal. You'll find them presented in the portal UI somewhere. You'll be able to go and try them out. They typically don't have an SLA attached to them, which means don't run a production service on it unless otherwise notified by Microsoft. And they generally run at a lower cost than what the final production service will also run at as well. So these are good things to learn about in advance of them becoming more generally available to your organisation or to the community. And it's a good way to get ahead of the curve. So if you see about a public preview, maybe you aren't necessarily planning on using it initially, but it's still good to go and have a bit of a play with it, and maybe it will cost you a little bit less to learn about it. I've tried to make these kind of specific to the IT Pro community, but there might be a few crossovers here into the dev space. The app service Web Apps for Containers has been running the Linux-based Docker images for a while. We now have the ability with this public preview, the first one I've got up here, to do the same with Windows containers. So we're going to start to see, probably over the next 6 to 12 months, Windows containers become more prevalent across the platform. So things like AKS, Azure Kubernetes Service, will start to support containers once they make Kubernetes 1.10 available in the platform. And the app service Web Apps for Containers is now offering an in-preview version of Windows container support. So if that's a space you play a lot in, it's definitely an interesting one to have a look at if you want to move away from maybe hosting on virtual machines or having to worry about large-scale orchestration with the likes of Kubernetes. Azure Service Fabric Mesh. Anyone here who knows what Service Fabric is? 2 people, 3 people, 1 person kind of put their hand up and was like, I don't really want to admit that I know about it. I wish I didn't have to know about it. So Service Fabric is Microsoft's quite mature workload orchestration platform that runs a lot of the underlying services that you use in Azure and in Office 365. Service Fabric Mesh is kind of a re-envisioning of that from a as a service offering standpoint. Takes away a lot of the mechanics of having to set up and run Service Fabric. If you are interested in doing workloads without having to worry about necessarily doing orchestration with the likes of Kubernetes, Service Fabric is worth having a look at. There's a whole raft of documentation Microsoft's written about when do I choose Kubernetes, when do I choose Service Fabric, when do I choose Windows, when do I choose Linux, and all those sorts of things for your workloads. Definitely worth having a look at. Azure Virtual WAN, I won't go too much into this because Marc and Nathan are going to be talking to you about this tonight. I'm assuming you're here to hear about that and not me, so we'll just brush over that. And then Azure Firewall, it's kind of one of those services everyone's been asking for a while is kind of, I don't want to have to set up a checkpoint. I don't want to have to set up one of the other multitude of third-party vendor virtual appliances that allow me to do firewalling on my virtual networks. Now with the Azure Firewall, you have a first-party offering from Microsoft that allows you to do those sorts of features in a highly available and scalable fashion. So that's the basic high-level overview of firewall. Any questions on that one? And I'll direct you to Marc. Yes?
Does it do a WAF function as well or not?
Does it do
WAF function as well?
a WAF function? I don't know. Does it do a WAF function? That's a good question.
The application,
Yeah, I know application gateway is kind of the go-to for that.
So generally firewalls outbound, the downside's inbound.
Yep. So it's a run-of-the-mill firewall. It does all the different, it's not just a layer, and correct me, layer 7 stuff. It does the layer 7 and the layer 4 firewalling. So it's kind of, it's the sort of firewall you would expect to be working with if you were doing stuff with like the likes of checkpoints. IoT Hub, manual failover. So IoT Hub is a large-scale way of receiving and sending messages in IoT solutions. With this manual failover, you now have the ability to control when a failover event occurs. So maybe you want to do a test DR scenario to allow you to fail over between, say, Australia Southeast and Australia East for your IoT hub. You now have the ability to control that manually rather than to allow the platform to determine when that's happening. Maybe the metrics that the platform's using to determine failover events isn't suitable for your enterprise or your organisation. Now you have a bit more control over that. This is in preview. Cosmos DB JavaScript 2 version 2 SDK definitely falls into the developer space. There's been a version 1 SDK available for Node developers for a while. Some of the guys out of the functions team who are heavy in JavaScript went over and helped rewrite this from the ground up. That's in public preview at the moment. So if you've done a lot of Node, Cosmos DB type development, this is one you definitely want to go and have a look at. I've done a lot of tidy up work and hopefully improved the underlying capabilities of the platform. Dev spaces for Azure Kubernetes service. This one's really cool from a development team standpoint. If you're doing a lot of kind of cloud native, container native development using Kubernetes and Docker, or if you're hosting workloads in production that are running on those two platforms, this allows you to quickly run up components of those environments and debug them straight out of whatever your IDE tool is. So I saw a demo of this back in March before Container Camp, and it's kind of mind-blowing. If you think about microservices architectures in production, really hard to debug those things locally as a developer or even in test. With this, you can inject, say, one microservice that you're attached to in a debug mode and then just route specific requests through that microservice, and the rest of them will go through all of the, say, the production or the test microservices that the environment's running. Super powerful. If you're not in that space, probably a bit hard to wrap your head around, but I think we'll see a lot more news around that with obviously the focus on Kubernetes and Docker workloads. And then the last one, Azure Monitor Smart Groups. So it gives you a bit more control about how you route monitoring alerts out of your monitor setup rather than having to do it individually. You now have the idea of smart groups that you can do things like route to different groups at different times of the day. Interesting changes there. So these are all in preview. Go have a play with them, but they're not yet production ready or backed by an SLA. Last one, and these are usually a lot longer. It's been summer. We've got Ignite coming up in 4 weeks, so there's a lot of stuff probably being held back to go out the door at Ignite. Normally we would have probably a couple of slides for each of these areas. So generally available. This is the final tier that services graduate to in Azure. These are services you pay full price for, and they're backed by a published service level agreement, which is an availability SLA. So if it dips below that, there is recourse in place for you as a subscriber if you have a service that has that SLA on it. Microsoft's done a lot of work around making MySQL and PostgreSQL as a service offerings as part of their Azure database for MySQL and Azure database for PostgreSQL offerings. In the last couple of months, we've seen the VNet connectivity come up for those two services. So if you're running traditional virtual machine-based workloads maybe you want to secure them, you want to lock them down so that the services like MySQL and PostgreSQL are only available on your private VNet. You now have the ability to do that by switching on the VNet connectivity option for both of these, and that's generally available. So that went through a very short window of preview, so it's good to see. App service environments, so if you do high compliance hosting using app service and you want to have guaranteed separation between yourself and other tenants inside of Azure, you generally end up on app service environments. We now have the ability to run Linux in those environments in a generally available fashion. Till this, you could do it in preview, and prior to, I think probably the last 6 months, you didn't have Linux as an option in app service. But it's good to see Microsoft moving into that space. Azure SQL Database, reserved capacity. So Microsoft's allowing you to kind of go in and chunk off and say, I think I'm going to use this amount of capacity. They start to like to do those sorts of things. It gives them the ability to do capacity planning for their data centers. The trade-off is that you get that reserved capacity at a lower price than you would do if you were actually just turning up and saying, give me the capacity on demand. So it works both ways. You get a lower price, Microsoft gets a bit more control over what they think is going to be peak demand in their data centers. Security Center, adaptive application controls. So this allows you to determine at an application level what is and isn't acceptable traffic, and allow you to set alerts based on what behaviours are going on inside of applications. The Security Center is getting broader in terms of what it's able to do, so it's going beyond just virtual machines and virtual networks and moving more into the application space now. So super powerful stuff if you've got, say, complex microservice-based architectures. Maybe you want to only allow some parts of those architectures to talk to certain other parts. You can now flag those sorts of things with Security Center. Yes?
Does that come to containers as well?
Good question. I don't know, but I can find out for you.
What was the question?
Do those adaptive application controls look after containers? I don't believe they do, but I can have a look.
It basically uses the agent inside of the VM. So if you get the agent in the container, yeah.
Potentially. I don't know that you probably have to build your baseline image off of a machine image that already has the agent installed. Anyway, we can talk about it offline. Yeah, but yeah. Azure File Sync. So this is about syncing files off of machines, say in your data center or other locations. It's now GA. I don't know, Mark. What's your take on Azure File Sync use case? Best use cases for that?
If you want to save storage costs in Azure, you can set up. Azure's got. Best use case for Azure File Sync. Who's familiar with Azure File Sync? Okay, 2 people. Okay, so in Azure, there's no such concept of shared storage anymore. So basically, with Azure File Sync, what you can do is set up cloud tiering at 99%, which means 99% of the drive, the local drive on the virtual machine, has got no data on it. It's just like all stubs. And so the back end is Azure Files. So essentially, when the VM starts up or the virtual server starts up, you've got your volume that maps at the system level, computer level, and not the user level. So yes, it's like an SMB share, but the computer's doing that mapping because of the Azure File Sync agent. Follow? So that's basically a good use case for it. You can sort of save on storage within Azure.
Branch tech, so branch computing. So if you're a main location with branch offices, it's ideal. If you know StoreSimple, it's a great replacement for StoreSimple. I don't want to say that, but.
So is your mic on or off? Yeah, it's off. It's like everyone on. What did you say? Okay, Azure Maps. So Azure Maps is a developer-centric service. A set of APIs that allows you to do map-type operations. It's kind of a secret service that snuck out a little bit. Not a lot of people know about it. It's quite interesting because they've added the ability to do IP address lookup, so you can basically do like geo-IPs. We all know how accurate that is, but you know where it's accurate, it's useful. And you can do geocoding and matrix routing using this service as well. So if you've got an application that you're building or running that needs to do geocoding or route planning, you now have an API that you can call to do that for you. It's really actually a solid service. And the one I didn't mention up there because it's not new is the time zone stuff. And if anyone of you has written software, you'll be going, yeah, I could have done with a time zone service at some point. And if you haven't written software, you'll be wondering what all the big deal is about time zones. That's all right. Azure SQL Data Sync. This thing has had the longest preview, I think, of any service in Azure. I think it's probably been in preview well over 2 years. It's finally generally available. So it means it has an SLA and it's a real thing and it's got support. So it's good to see that. AKS, Azure Kubernetes Service, launched in Australia East. It's only in Australia East at the moment, hopefully not too far away for Australia Southeast. And then we have the M-Series VMs launching in Australia East as well. And these things are certified for SAP HANA workloads as well. So if you're doing SAP or SAP workloads, they're kind of your go-tos if you want things to run and perform as you expect. That's it. One more. Announcements. Ethereum, because it wouldn't be a meetup without a mention of blockchain. Ethereum Proof of Authority is now on Azure, so it's not just proof of work. You can now stand up proof of authority inside of Azure as well, which is great if you're doing a lot of work using blockchain as a kind of a foundation for your work. Azure App Service. So Microsoft's been working hard to make sure that their platform supports as many of the standard development languages out there that they can. So they worked with Oracle to make sure Java SC on Linux was available in App Service. Azure Advisor now has a bunch of new recommendations baked into it. If you're running an Azure subscription or multiple subscriptions today, definitely worth having a look at Advisor for the sorts of tips and recommendations it will give you. The new ones that they've announced are VM reserved instances, so starting to look at some of the workloads you're running and suggesting where you might be able to save some money by moving a workload to a reserved instance. And doing some stuff around traffic manager tuning. So looking at the traffic patterns on your traffic manager setup and maybe recommending different endpoints and different policy configurations you can use for traffic manager. Visual Studio Code in Cloud Shell. So if you use Cloud Shell, go into the console and type code and Visual Studio Code will open in your web browser. It's not quite the full VS Code experience just yet, but it's coming. It's a quick and easy editor and one you can actually escape from, unlike VI. So no one laughed at that. All right, never mind. And then the big one, I put an asterisk next to it. End of support for Server and SQL Server 2008 and 2008 R2. Hands up if you haven't heard about that. Everybody's heard about it. Good. Does everybody understand the offer that Microsoft has in place for moving those workloads to Azure and what benefits you get? No? Okay, so there's a 3-year extension for security updates if you move your SQL Server 2008, 2008 R2 and Windows Server 2008, Windows Server 2008 R2 workloads into Azure. It's kind of a benefit you're going to get if you make that decision. Otherwise, it's time to upgrade. And if you haven't upgraded, why haven't you upgraded? And I realised I missed one out of here, out of all of those things. I did. I'll leave that up. So there was one more I missed around the reserved instance VM flexibility. So Microsoft introduced the idea of VM groups, and now you can move between VM sizes in a VM group, even with reserved instances, and retain the reserved instance pricing benefit that you've signed up for. So the reserved instance space in the IaaS offering that Microsoft has, I think they're kind of trying to drive a lot more flexibility that differentiates themselves from other competitors in the market, to the point that I think, and correct me if I'm wrong, Mark, there's around the reserved instances, you have some flexibility around being able to hand back unused reserved instance capacity as well.
Yeah, you can.
Yeah, which you don't get elsewhere. You kind of, you've paid for it, you've committed to it. You didn't make a mistake. Too bad. Sorry. All right, that's it for me. I think food is here, so we might just do a quick takeover.
Sorry to interrupt everybody. Let's get back into it. So we're going to Marc and Nathan doing the main thing on Azure Virtual WAN. Just before we get cracking, keep in mind after the presentation, don't run away. We've got a lot of experts in the room. I mean, a few Microsoft people, obviously. We also have Steve hanging around for end-use compute, along with Ben. We got Phil, Andre. We got missing people. But anyway, so if you need anything, if you have questions, if you want to discuss anything, just come and see me. I can direct you to the right person to talk to. All right. Anyway, here's my key.
Hello, everybody. So I'm Marc Kean. I'm from Microsoft in Australia. So I'm a TSP, which anyone know what it stands for?
Oh, yep.
Totally special person.
Nice. Yes. And
Technical solutions professional.
pre-sales technical specialist. And so the way it works is we've got like about 4 different people in the sales arm. So it goes from like non-technical right up to the technical. And I'm pretty much last on the line. So I'm the technical, level 300, 400 of Azure infrastructure. So I cover like all the compute stuff, storage, network, containers, DevOps, deployment, all that sort of stuff for all of our enterprise customers in Microsoft in Australia, based in Sydney. We've also got over here from Riverbed, Nathan Chan. And Nathan Chan's been at Riverbed for 8 years. He's a Riverbed expert, SE manager, which is a solutions engineer. Yep, okay. All right, let's crack on. So basically today we're going to be talking about Azure Virtual WAN. We're going to go through like a bit of a history or a backstory about Azure as a whole, an overview of what our data centers are like. Do you guys, who here knows about the complexity or the sheer scale of Azure?
It's like 2 servers, right?
2 servers, yeah, there's definitely 2 servers. Definitely 2 servers in there.
You just put it on.
Yeah.
That's it. Okay, so we'll go through, have a look at Azure in the background, what it is, just to give you an idea of what we're talking about, the hyperscale, and then we'll go into the subject virtual WAN. There's a few slide decks on it, take some questions, and then we've got Nathan over here, who's very kindly offered to join us for a demo. Okay, so a real life demo, we'll set it up, grab some beers while it's being set up. It's going to probably take about maybe 10, 15 minutes to provision itself, so we'll roll through it. Okay, so basically, here's our data centers. Okay, that's one of our data centers in Quincy, in Washington. So, anyone want to take a... Sorry?
Is that each US one?
No, West. West US, either 1 or 2. Anyone want to take a guess at how many megawatts these buildings are? 8.5. Sorry, they're 11 megawatts. This line that you can see here, down the middle, and these lines here are what's called an engineering spine. So there's 2 engineering spines connected to each data center for redundancy, which covers 4 things: power, cooling, network, and telemetry. So we have telemetry right down at the bottom level. So if you use log analytics in Azure and you do those queries, those new queries that you do, well, guess what? Back in the behind the scenes, our engineering team use those exact queries right down to the hardware level. Okay, just to show you the power behind those queries. Now, that there is essentially one region. If you notice, there's like multiple data centers in a region. In Sydney, slightly different. We've got pretty much the same thing, multiple data centers in Sydney, in the region, and there's like 4 data centers spread across. Probably not that close, but it's still pretty close. And in case you don't know where it is, there's another photo of it there. Oh, by the way, let me just go back. These fields on the left and the right is room to expand. There's actually another photo that I can show you later, but basically we're already starting to build data centers, more of them.
Any what?
No.
Yeah, right.
And that's where it is, basically. Okay, here's another photo of another data center in Cheyenne. So same deal. Small data centers, more room to expand. Yeah. When we go into a region, we basically make sure that there's enough room there to expand. Otherwise, we're going to be in trouble. Cloud's just taken off. That's where that data center is, Cheyenne. Okay, and here's a photo of inside of the data center. You notice there's concrete floors down the bottom. That's so we can get the engineering spine underneath. So let's go through. So basically, the way it works is we've got so many regions around the world, okay, more regions than any other public cloud provider that you know of, combined, essentially. And so the idea behind that is, yes, we've got global reach, local presence, which means any customers, so we're in 100 countries, like available in 100 countries worldwide, around the world. So that means any of those people in those 100 countries can jump on, sign up to Azure, consume Azure, use the services, and deploy services anywhere around the world across the globe. So if you've got customers, if you're an enterprise customer, and you've got customers sort of like on the other side of the world, you can easily spin up a service over there and then have like super low latency. Okay, so 50 regions worldwide. That number's climbing. The slide is slightly old. We've got 54 regions now. Yeah, 140 countries around the world where you can jump on. So just to give you an idea of the scale, down in Australia, down here, we've got the 2 Canberra data centres here on the right-hand side, although Australia's southeast. So the data centres in Canberra are set up for in buildings that we don't own. We've done that strategically. So in Australia, all the data centres, Australia East and Melbourne, are owned by other people other than Microsoft, because Microsoft's an international company. We've done that for a reason, so we can get the government regulations, like top secret, secret, unclassified, all those type of regulations, right? And so for us to get the Canberra data centres in here, to get the government on play, there's protected status, and then there's secret and top secret. So top secret's the top one. So those data centres, if you've got secret classifications, you can host your stuff in there, basically. Okay? And the reason for that is because we don't own that data centre. It's owned and operated by Australians, which is a big thing with this. Actually, I'll just go back just quickly. Just on that, so we've got the Melbourne region down the bottom, Sydney region up the top, same deal. They're also to the same status. So if you want to host your top secret, or not top secret, but protected workloads in there, you can. Okay, yeah, go.
When did the Africa data centers come online?
In this year, sometime.
Yeah, right. Okay.
Yep.
Because I've seen that map, but
Yep.
that's new.
Yep.
Yeah.
Okay, so a few stats probably blow you away. So 2 million miles of fibre around the world. The speed of our network around the world, and we've got 2 links to every region. 72 terabits per second. 100 plus data centres. So remember, as I said before, one region comprises of more than one data centre. And millions of servers. Not 2 servers, but you can do 2 servers if you want. Okay. No, you can't. Okay. So largest networks on the planet. So it literally is. Okay, here's one of our barges. So that's that there. Anyone know where that is?
That'd be a barge.
So that's about a year ago. There was an announcement, the Maria cable across the Atlantic. So it goes from Spain to Virginia. And that was a joint venture between Facebook and Microsoft. So yeah, so we literally lay our own cables under the sea. To give you an idea, we'll go through a few photos here. 4,000 miles is the total length. There it is on the barge. So the width of that fibre optic cable there is, anyone want to take a guess? It's about that wide. So it's 1.5 times the speed of your, 1.5 times the width of your garden hose. So it's got 8 strands of fibre in there. It's covered in like a plastic coating and waterproof coating as well on top of it. So that's literally what's running along the ocean floor, 3 kilometres or 3.5 kilometres deep. And every 71 kilometres there's like a repeater, amplify, repeat, and so forth. And that's the photos of them rolling it out. So yeah, that's what we do. So we've been doing data centres for quite some time, back since 1989 when we rolled out our first data centre. So back then, right across to today, as we go through, got the traditional data centres. We started with air conditioning. Okay, as we move forward through there, we used to do the IT packs, yeah? So everything was like in a pack, all the racks are already stacked up, all the servers are already connected. You just plug them in and away you go. It's all modular. Today, this is what it looks like, and we don't use any air conditioning. Okay, so it's all water cooled. So the air comes in, Water's pumped in at 14 degrees. Okay, the hot air from the back of the servers goes through a radiator, which is filled with water. And then 16-degree water is pumped back into the system out the back, and it's recooled and pumped back in at 14 degrees. And the process just continues. Okay. So as I said before, the top one here, telemetry, is the engineering spine, which is the four things: network, power, cooling, and telemetry at the bottom level, at the hardware level, so we can monitor pretty much everything inside the data center. So if anything goes down, we know about it. Okay. We use a lot of AI, machine learning, our own products to detect any failures or any predictions of hardware faults that could arise. Okay. So we'll get in there and fix it. So that'll give you the reliability that you're used to, and also the efficiency as well. Okay, and the efficiency comes with no air conditioning. It's just basically doing the whole water cooling aspect. Okay, so with that, I mean, the networks are basically changing. Life is changing. Companies are changing. Everything's going through this change at the moment, like this journey to the cloud. Like, I talk to quite a lot of customers on a daily basis, and pretty much everyone's in the same boat. Over half of them have pretty much said, you know what, we want to move everything to the cloud. How do we get there? How do we do it? You've probably heard this story before, like everyone's pretty much moving to the cloud. If not there yet, they will be there. It's pretty much a no-brainer. And so you've got to work out how you're going to architect that network and get it set up in a way so it is secure and you can trust it. A lot more people are going mobile. And also, too, you want some visibility over your security as well. So connections coming in from outside, you want to know if they're malicious IP addresses or not. So Azure Security Center, which sits across all of this, is a product that we've got, and we can detect what traffic's coming in and out of the data center and the platform and your services that are running inside of Azure. And we know pretty much before anybody else that, okay, a certain IP address is malicious or what traffic that is, because we've got, I mean, imagine you've got Xbox, you've got Office 365, you've got all the consumer products, you've got Azure, other customers, tenants around the world. All of that network traffic is all anonymously captured, and we can see exactly what's happening with that. And so we put that that data sort of back into the system. We can display that back to you guys for benefits. I think there's more food here, guys, if you want to grab some food. Okay. So your needs for the network. So remote users, go through this quickly. Scalability, performance, network security, as I talked about before. You want the policies in place to control who has access and who doesn't, what comes in, what goes out. Okay, and our vision. So we want Office 365 and Azure to be pretty much equal for connectivity purposes. I'll go back like about 2 years ago roughly, we had issues with a lot of people logging support tickets to Microsoft fixing up express route issues. Microsoft peering, essentially, express route connectivity to Office 365, right? About 90% of our calls are all due to customer error. And we looked at it and we thought to ourselves, well, okay, well, if 90% are due to customer error, what can we do as a company to help these customers consume our product? So what we decided to do was essentially bring the data center and bring the services one step closer to the customer. And that's what's commonly referred to as the last mile. Okay, so essentially what we've done is pretty much done the same thing what you get from express route, low latency to the data center, but because we've brought the services back closer, there's essentially no need for the connection, express route connections. And that's why now we recommend with Office 365, for example, is if you're going to connect to the services, you just go over the public internet and forget about using express route. You might remember I said before about the edge nodes. We've got 100 to 140 edge nodes around the country. That's pretty much what they're used for. Which brings us to Virtual WAN. So Virtual WAN is a new product. It's in preview. It was announced a few months ago. And what it is essentially is a joint venture between us and our partners, our vendors. We're launching with 2 here that you see up on the board. So Citrix and Riverbed to kick things off. And so essentially what it is a service which makes it easier for you to connect to Azure, similar to the Office 365 mentality where we've brought the data center one step closer to the customer. We've pretty much done the same thing with virtual WAN, okay? Historically or currently, if you want to connect to Azure, you either do three things: a point-to-site VPN, which is from your laptop straight up to the Azure data center, or you can do a site-to-site VPN across the public internet, which goes from your network across to the data center, which goes over the public internet. Remember, there's quite a few routes, and depending on what ISP that you pick, it's going to make a difference to your latency. And the third way of doing it is express route, which is like a full, pretty complex way of setting it up. If you talk about express route to a lot of customers, they freak out. There's a lot of BGP routing and so forth. And trying to get that all hooked up is somewhat complex. So this is why we've come out with Virtual WAN. It's somewhat a copy of the Office 365 solution in a way. Okay, so the way it works. As you can see on the board here, we've got down the bottom here the on-prem branch sites. Okay, so branch site 1, branch site 2. Okay, up the top you've got 2 VNets in Azure in the same region. Okay, remember this is in preview. There's more features coming out shortly. The center point to all of this is called the Virtual WAN. Okay, part of the Virtual WAN is a virtual hub. Okay, the virtual hub is essentially the edge site. So it's not the region. It's, remember, the one step closer to the customer, the last mile. That's essentially the virtual hub. So you do a site-to-site VPN, or you don't manually. You click a button, it configures itself automatically, the beauty of Riverbed. It makes a site-to-site VPN connection from on-prem to the virtual hub. Yeah? So the virtual hub is essentially just a VPN device, which will, I was told today, that eventually come out with no limit of the amount of connections can have to it, infinite connections. Virtual hub, 1 hub per region, okay? Remember that, 1 hub per region. Connecting to that, down the bottom here we've got 2 connections in for essentially redundancy, and you've got the VNets that are plugging into the virtual hub as well. Yes, question?
So does on-premise connect via site-to-site VPN?
Yes.
To the virtual hub?
Correct.
And the virtual hub obviously then has to have a VPN gateway configured in order to get the connection back on-prem.
Okay, so the question was on-site. So 2 questions. On-site was, do they have to have a VPN device to connect out? Yes, it's a SD-WAN appliance like Citrix or Riverbed, essentially. And the other question was, does the virtual hub have to have a site VPN gateway?
VPN gateway,
Yeah, it does. Yep. That's pretty much what it is. It's a VPN device. Yes, question? How do you failover? That is a, well, you can have multiple branch sites here. It's a bit of a manual process, but you can have like this branch site essentially connecting to another virtual hub later on, not now, it's coming. And you can essentially have 2 paths into Azure, okay? As I said before, 1 virtual hub per region, so you couldn't have essentially 2 paths from here to here, it's pointless. You'd have another connection from here to another virtual hub. Imagine this is Melbourne up here, yeah, and that would be your, if this goes down, you fail over through here. Okay, so setting it up, step 1, everything revolves around the virtual WAN. Okay, topic of this talk. Step 2, upload your sites. Now you might be thinking, hang on, what are sites? Sites will be explained very shortly by Nathan from Riverbed. Okay, sites are like a term, it's essentially branch sites basically. So that whole process is manual. You set up your Azure Access on your SDWAN device, okay, which is your credentials. It's essentially a service principal in Azure AD. It has access to, this is the whole beautiful thing about it, is once you get all this set up, the SD-WAN appliance on-prem talks to your subscription. It pulls out all the information from your subscription, your VNet configuration, your virtual WAN configuration. It says, oh, okay, I've got all this, I've got all these address spaces, I'll go and set myself up. You walk away, get a coffee, come back, and it's done. Okay? It's select a hub. So yeah, virtual WAN, then you select a hub. You can have multiple hubs in a virtual WAN. Config management, automatic download. So this is where it all automatically sets up by itself. Questions? Okay. So here's another one, another option, way of looking at it here. You've got virtual WAN in the middle here, the center point, and you've got multiple hubs around, okay? So you can have more than one hub. So these are in different regions. As I said before, one hub per region, okay? Region 1, 2, 3, for example, all part of the same WAN. And you've got your branch sites all connecting in. Actually, there's one thing I'll mention, which I sort of didn't mention before, which is one vital piece of information, is the whole idea behind this is you connect in from your branch sites into the virtual hub, which is the last mile. From then, any connectivity into Azure is literally across our backbone. So, let me give you an example. This branch site here wants to get to this branch site here, right? All it's got to do is go to this hub here, which is last mile, which is pretty much nothing. It uses our backbone to go to a different region, like could be Melbourne to Sydney or Sydney to Singapore for that matter, right? Our backbone, and then it goes out from the local hub back out to the branch site, okay? So remember I said before, we got 72 terabits per second speed across our networks around the world, which is blistering fast. The stat is about 35 million simultaneous high definition videos can be watched at the same time across that speed. And that's coming soon, point to site. So you've got your users out here, they want to get in, it's on the way. Yes?
So what happens if you add, what happens if I add another subnet up there? Do I need to do anything on the virtual hubs, or will it automatically go via the routing protocol?
Okay, question was, if you want to add another subnet to up here in Azure, like into the VNet, so just going back, the VNets itself are like embraced by they're wrapped around by like an address space essentially, okay? So like a /16 address or /8, for example, you create multiple subnets within that VNet. So as soon as you create a subnet within that VNet's already connected to the hub, that'll just show up.
Yeah, what if I was to add another /16? Right?
Like another VNet?
Yeah.
If you wanted to create another VNet, you would essentially go into the portal and you'd add that VNet into the virtual WAN and attach it to the hub.
Right, but I don't need to do anything on the site.
No, no.
Everything goes better, everything goes. So the idea is that virtual WAN has a routing internally, and it knows what VNets to connect to, what VNets to connect to coming in, and what subnets you have at the end of each of those. Get after the content.
Second, after some kind of downtime, outage window when we add a new subnet?
No, all these other ones will basically stay online. It reconfigures itself. You'll see it in a sec. It's pretty. I was blown away when I saw it. Okay, so just a couple of more slides and we'll hand over to Nathan. So here we got best practice connectivity. So as I said before, the branch sites, if they want to talk to each other, if you wanted to go branch to branch, you could, but that's how to scope for virtual WAN, okay? Generally, branch sites talk to each other via the virtual WAN, via the virtual hub, yeah? That's how they communicate with one another. VNets are slightly different. Don't ask me why, but they are slightly different. VNets, if they want to talk to each other, they're not going to go via the virtual hub. VNets are not like branch sites. If the VNet wants to talk to another VNet, you've got to do what's called VNet peering between the two, yeah? Question?
So what's the virtual hub? Is it like an appliance running?
What's that, sorry?
What's the hubs? The virtual hubs? Appliances?
The box on-prem is an SDWAN appliance. So Riverbed, Citrix, Cisco, and the list goes on.
So for a branch, though, typical branch, you might have either South Nation or NBN, or you have listening.
Doesn't matter. It doesn't matter what ISP you've got. It's basically a site-to-site VPN from here to there.
But that's for a pure cloud-based solution. But what about if you've got a big net office or a couple of internal data centers that you want to...
Express route, for example, you can bring that in. Express route integration for large data centers, for large chunks of data that's coming soon. It'll be integrated with this.
You might spill some traffic out here like that.
Yeah, and just on that, so the question is talking about the enterprise level connectivity through data centers. And so, yeah, express route integration will come soon, but also too, with this site-to-site VPN, you'll have BGP routing set up. So you can advertise your prefixes down here, and so the routes will automatically be set up. So if you want to do the enterprise level routing, you can pretty much do that. It's still in preview. So let me just explain this slide for a sec. So I've got a red X here. It's a bit misleading, I know, but just as I said before, if you want to connect the two VNets together, you have to do a VNet peer between the two. It looks like you don't do a VNet peer. There's a red X. The red X is actually indicating that you can't connect these two spokes via the hub. That's all it's doing. You've got to do a VNet peer essentially. Okay, one last slide. We'll hand over to Nathan. As I said, okay, different between that slide here. 2 spokes, 1 hub. Yeah, virtual hub. This one here got 2 spokes, another hub, and another hub. So this hub is like essentially a virtual appliance. So at the moment in Azure, it's very, very common that I see is a lot of customers set up like one VNet, which is focused as like a hub VNet with all the virtual appliances on there, and all the traffic routes via that VNet for security, like Palo Alto's or Riverbed or whichever else, and comes back to on-prem or out to the internet. They control all of it from that hub, and they've got spokes hanging off it. That's essentially the common topology that people are deploying in Azure on our network, right? And so that essentially is what it looks like. And with that topology, you can actually route traffic from VNet spoke 1 to VNet spoke 2 via the hub, because you control that network appliance here. It's basically using UDR next top. Use this one for the user-defined route. Okay, using a remote gateway here and the backup there. So if you want to set that up, you can. And then the virtual appliance here that connects to the virtual hub. Okay, so that's it for me. Any last questions before I hand over to Nathan?
How does it interact with the single firewall that was mentioned earlier?
Azure Firewall is completely different. Right. Azure Firewall, think of a virtual appliance like Halos or Riverbed. Yeah, yes, correct. Azure Firewall is like that. Yeah, exactly. Okay, I'll hand over to Nathan Chan from Riverbed. Thanks, guys.
Thank you, Mark. So tonight, as sort of Mark alluded to, I'm going to give you a little bit of a demo of our Riverbed SteelConnect SDWAN offering and how we work with the Azure Virtual WAN. Just give you a little background of who Riverbed is. Been around for a very long time. Back in 2002, we're greater than 1 billion revenue, and we have a lot of people and a lot of offices around the world, 2,500 people plus. And lots and lots and lots of customers who highly recommend us. A lot of people, and I'm sort of in the room here, I'll ask the question is, who knows us for our Steelhead? This is our product that Riverbed was born on, and it was built around our WAN optimization. But Riverbed has grown quite significantly in our product portfolio, and we are no longer just around about WAN optimization. We are actually a full digital performance platform. So we have end-user experience monitoring, network performance monitoring, IT infrastructure monitoring, and application performance monitoring in that digital experience space. As part of our cloud networking, we have that WAN optimization component, but also now we also include the new SD-WAN and SD-LAN components. And then at our cloud edge, we also have some functions where we have the ability to present storage all the way out into our branch. As you can see, one of our biggest technology alliances is with Microsoft. We have a number of other alliances with other vendors. So today we're going to have a bit of a chat about some of the SD-WAN component, which is this little piece down here in the cloud networking. So I want to give you a little bit of terminology of how our SteelConnect product works. This is basically the building blocks of how we build our components in our cloud portal. So fundamentally, we break it down into these sort of 4 components. The site, which is the physical location of where our SD-WAN site is, or where our branch is. We have this idea of a zone, which is the subnet or subnets that sit at that particular location. We have this idea of an uplink, which is the physical connectivity from that site, and that may connect to a WAN, the same WAN, multiple WANs, or different connectivity methods. So that could be like an LTE or an MPLS or an internet or whatever it might be. And then by having all of these site definitions and uplink definitions and WAN definitions and zone definitions, the whole of the SD-WAN architecture then knows about one site, knows about all other sites. So today in our little bit of our demo I'm going to show you around the Azure Virtual WAN, I'm going to show you how we configure and connect a couple of branches, or a branch and a data center in this particular case, which has a zone or a subnet, a single uplink, which is an internet connection in this particular case. And we're going to be connecting it into that Azure Virtual WAN, which in this particular case will be the Australia East Hub. At the same time, I'm also going to show you how we would then include a VNet peer, so that an existing VNet that happens to already exist in my Australia East Hub will suddenly be part of that Azure Virtual WAN. So let me jump onto the browser here. So this is the SteelConnect Manager. The SteelConnect Manager shows all of my sites that I currently have configured. So right now, just to speed this demo up, I've already configured my data center, which is located in Sydney, as per that little diagram I just showed you. So let me quickly show you those building blocks I mentioned. So that's site definition, which is where we have our headquarters, physical location. We have WANs, so in this particular case, I've just configured internet, but we could also have an MPLS WAN or an LTE WAN, or whatever other networks we have connectivity for. We have that uplink. So as you can see, we have that uplink from the headquarters via the internet, and I'm currently configured it for a gateway, which I've already pre-provisioned into the data center. And as you can see, it's been given an IP address in the internal network, and it's added out into the external network via a public-facing IP address. Also in that headquarters, you'll see I have a zone, which is an IP address, which is in this particular case a 172.16.00/24 network. And because we are the gateway, we are the router at that particular location, we become the default gateway. So we are 172.16.0.1, and because we are the gateway of that site, I'm also handing out DHCP addresses to my network. So we can have a quick look at that and see what we've been allocating out. So 0.2 through to 0.254 is all being handed out to any clients that sit on that environment. So what I'm going to show you now is I'm also going to show you how we create a new site and how quick and easy it is to create a new site. So in this particular case, I'm going to create a new site called Vanuatu. Vanuatu, if I can spell. This is the building block of the first component, which is the idea of physical location. In this case, it's going to be in Port Vila. And Vanuatu. And Waight, I believe, is the time zone. And submit. So by just creating that physical location, we automatically apply a template. Now the first part of that template is, and this is a default template by the way, the first part of that template is we always create an uplink to the internet. So by default, Vanuatu always has, or we always define that there's an internet uplink from a brand new site. So as you can see, Vanuatu has an uplink to the internet. The other thing we also automatically create is a zone. So the next available subnet, which we have allocated, so we by default allocate subnets out of 172.16. You can see that the Vanuatu zone has been created automatically as part of definition of that site. Now, if, for example, we had multiple zones at that particular, or multiple networks at that particular location, we could also create a new one. So we could say, actually, you know what? I've also got a guest Wi-Fi network sitting at that particular location. I wanted to assign the next IP address out of that subnet as well that I'm allocating. And Bob's your uncle, you now have two networks. A LAN network, which could be your corporate. And by the way, if you wanted to do that, you could actually go in there and change the name of that network to corporate, just for clarity's sake. And then you'll have your guest Wi-Fi network. So that's how you create the zones and definitions. Now let me come across here into our Microsoft Azure portal. So as part of the creation of the Azure Virtual WAN, I've gone ahead and created this because it actually takes about half an hour to build the virtual WAN for the very first time, or the hub in the virtual WAN. So as you can see, I've created an Australia East hub. That hub, in essence, behind the scenes is spinning up an IPsec termination point, and it's spinning up the relevant VMs to be able to do that. I've also created an authentication between the two. So if I go into my Azure configuration here, you'll see that I've actually configured access to my subscription. So basically, the SteelConnect Manager is using all REST APIs to be able to configure and manage and provision anything we want to do into the Microsoft Azure network. So at this point, I now have the ability, and I've got one more thing to do before I do that, is one of the requirements is we actually need to have our auto VPN disabled. So let me quickly just disable that. This means that we don't create connections directly between the two sites. We actually create the connections to the Microsoft hub in that particular location. So the first thing that we do as part of that creation is we then go into the Azure Virtual WAN and we add our sites. Now, one more thing, forgot to do it. We need to apply an appliance to that new location. So right now, Vanuatu, we created that template for it. We actually haven't told what appliance is going to be sitting in that physical location. So I'm going to go and allocate this device, this one that I have spare sitting here, which is already sitting and prepared, ready to go, just to make this demo go a little bit quicker in that particular location, and I'll allocate that device to that site. So now I have two devices, and if I jump onto my dashboard, you'll see that I have two physical locations now configured, and they're ready to go. So now I want them to be able to communicate to each other. So the next thing that needs to be done within the Azure portal is to add sites into the Azure Virtual WAN that I've created. So you can either add all sites, or if you wanted to, you can go be specific and just click on the ones you want. Now, because the SteelConnect Manager has API communication to the Azure portal with that particular set of credentials I added, it automatically can see any virtual WANs that I've created in that account. So I'm going to choose the one that I've already pre-built and submit that. Now, what's happening behind the scenes is the APIs are going away and doing everything they need to do. Now, what does that mean? Well, fundamentally, it's going to go and provision these sites automatically into the Microsoft Virtual Network, into the virtual hubs. Now, one thing that you have to do within the virtual hub is you have to authorize those sites to be allowed to be joining the network. So now you can see that these sites have suddenly popped up within the virtual hub. Now I'm going to go and click and confirm these two. Okay, just give it a second. It's still creating those, it's still updating that. So we'll give it one moment. Okay, it's still updating. So this is the communication and API calls that are happening between the SteelConnect Manager, which is our cloud portal, and the Azure cloud portal. So it takes 30 seconds to a minute or so for those to update between the two locations. And then once that happens, we'll be able to confirm them to be allowed to associate to the Australia East hub. Sometimes to do this, we just might speed this process up a little bit. All right, so we have the two sites successfully provisioned into the Azure hub. So now we can go and confirm those two sites. And what that means is that now they'll be allowed to communicate and create their IPsec tunnels to the Azure hub. Now, remembering that this is all done automatically. We don't need to go and download IPsec communication configurations or keys or anything else. All of this infrastructure and communication is done transparently between the two cloud portals for all intents and purposes. And they are automatically configuring the IPsec tunnels and the keys, the IP addresses that they are located at, and all those sort of things. So we'll give this a moment and we'll see. This will eventually move from unassociated sites to sites associated to a hub. You'll see that it's still in what's called a provisioning VPN site state. Now, while it's doing that, I'm going to show you just a quick little diagram of how this is sort of all what it's doing behind the scenes. And this is sort of Microsoft's document. So fundamentally what we're doing is we're creating these IPsec VPN connections to the virtual hub on these dual IP addresses. These are all example IP addresses, but it's going to be exactly the same for our particular example. So we're connecting two sites into the same virtual hub. So what that means is these sites will be able to communicate to each other via the virtual hub. If they happen to have a VNet located at that same virtual hub or on the virtual network, which is part of the virtual WAN, these sites will traverse into the virtual hub across the virtual WAN to get to the VNet or to the local VNet. In this particular case, I'm going to actually show you how we associate a VNet to the same virtual hub. So if I go back to Azure, you'll see this thing called Virtual Network Connections. So one of the things you can do within here is add a connection. Now, I've already provisioned a 11 subnet, 11.subnet in my VNet, in the Australian East location. So what I'm going to do is I'm going to actually allocate that particular subnet and call it VNet. And there you go. Those two resources have been allocated into the VNet. Have been allocated into the virtual hub. So now I'm going to also add my VNet, which is called 11.11.000 subnet, into this VNet as well, or into this virtual network as well. So that's going to add that peer. So if I go back to the sites now, you'll see that these sites are now associated to the Australia East hub. Now again, all automatically done, behind the scenes, configured. If you add more sites later on, you need to come in here and then confirm them to be added and allocated to that particular site. If you have other hubs around the world or in other states or wherever it might be, you allocate those particular, you'd create also another hub in those particular locations, associate the sites that are closest to that particular hub, join them in, and again, they'd be associated to the different hubs around the world, around the regions. But they're all part of the same virtual WAN. So now you can see that we've added a peering into the VNet, so the 11.subnet to the hub Australia East. So now we have not only two branch sites connected into the virtual WAN, but we also now have the 11.0.0 subnet, which is my VNet in Australia East, also connected into the virtual WAN. The last component that needs to happen now is that we need to automatically create those IPsec tunnels between those branches and the virtual and that virtual hub, or the Azure hub. So if I just do a quick little refresh on this. Now, this does take a little while. So behind the scenes, there are IPsec tunnels being formed, configurations being transferred between, swapping of information, all being done automatically. And so given enough time, and this takes around about probably 5 to 10 minutes, I could keep pressing refresh here and make it go faster, but I'll give it a little bit of time. But this will move from a provisioning VPN site state to establishing a VPN state to established. And you'll see this over time. So I'm going to let you just, I'll let this go for the time being, and we'll give it some time to see it happen. So as you can see in the back here, the VPNs are starting to establish between each of those branch appliances. So the one sitting in the data center in Sydney and the one sitting in Vanuatu, and they're establishing their connection now. You can see that Vanuatu has already gone from establishing VPN to active. And if I refresh the headquarters one, we might be able to even speed up the headquarters one to make it go from establishing VPN to active as well. And if we go back to the Azure portal, you'll start to see this being connected. So you'll see that both are already site provisioned and the actual connection is connected. As you can see, headquarters is still coming up. And finally, we have both sites active and connected into the Azure Virtual WAN. As I said, it does take about 10 to 15 minutes to them all come up. But that's behind the scenes. I think there's a few timers in there that just sort of back off and do it in a timely manner. So as you can see, both connections are now active and connected. When we look at the Microsoft Azure side of things, we can see both are connected and successfully provisioned and connected as well into the virtual hub, which is inside the virtual WAN. and we have a virtual network or a VNet allocated into the same virtual hub as well. So they all have now connectivity to each other. So thanks, guys. Appreciate your time, and look forward to having a chat to you if you guys have any interest in looking at the Riverbed SteelConnect SDWAN solution for access into the Microsoft Virtual WAN functionality. Talk to you soon. Thanks, guys. Bye.